Let's take a look at two examples from section 5.5. This is multiple angles and product to sum formulas. The only formulas that we're going to take a look at are these double angle formulas. And you don't have to worry about how they're derived, but we'll just take them and use them. Sine 2 theta is equal to 2 times sine u cos u. Tan 2u, cos of 2u, there are three different expressions for cos of 2u, and how do you know which one to use? It just depends on the situation, which one would be most handy. These are gotten from using some substitutions of the Pythagorean identities for cosine squared and for sine squared. Okay, so let's take a look at example 1. We have a trigonometric equation that we want to solve. 2 cos x plus sine 2x is equal to 0. Well, when we look at this, we don't have a cos squared or a sine squared, which we might use the Pythagorean identity. We don't have any common trig functions that we can factor out. So racking our brains with this, we say, well, let's take a look at sine of 2x. So sine of 2x is equal to 2 sine x cos x. And so what we're going to do is we're going to substitute this in for this term. So we bring down the 2 cos x, but instead of sine of 2x, we use 2 sine x cos x. And again, we got that from right here, this formula, okay? Now we have an expression that has a greatest common factor, and that greatest common factor is 2 and cos x. So when we pull out a 2 cos x from the first term, we're left with 1. And when we pull out the 2 cos x from the second term, we're left with sine x. Now that we have this expression factored, we can set each factor equal to 0 and solve. So either 2 cos x equals 0 or 1 plus sine x is equal to 0. So let's solve this one first. First, you would divide both sides by 2, and you would have cos x equals 0. Then you would grab your unit circle and find out where is the cos of x equal to 0, and that's at pi over 2 or 3 pi over 2. Remember the general solution? Since cosine has a period of 2 pi, we add plus 2 and pi to both of those values. Then we turn here. If 1 plus sine x is equal to 0, you would subtract 1 from both sides, and you would want to find where is the sine of x equal to -1. So again, go back and look at your unit circle, and the sine is the y, and we can find that this y coordinate, I can't seem to get mine, here we go, unit circle in the back of the book, the sine is the y, so at 3 pi over 2, we see that the sine is equal to -1. So we have 3 pi over 2 for x, and notice that we already had 3 pi over 2, so there's no need to write it again. So those are your two answers. Okay. Our second and last example, example 2, use the conditions below to find sine of 2x, cos of 2x theta, or tan of 2 theta. So we're given the cos of theta is equal to 5 over 13, and theta is between 3 pi over 2 and 2 pi. So remember that that would be the third quadrant. Here's 3 pi over 2, and here's 2 pi. The cos of theta is the adjacent over the hypotenuse. That's 5/13. Again, we use the Pythagorean theorem. Oop, I forgot one thing. That's going down, so that's a -12. Okay, now we use from the chart, the sine of 2 theta is equal to 2 times the sine of theta, cos theta. And what is the sine of theta? We get it right from our triangle. Sine is opposite over hypotenuse. So we'd have our 2 here. Then we would have negative 12 over 13. That's the sine of theta. And the cos of theta is adjacent over hypotenuse, or 5 over 13. And then we just simply multiply those together. 12 times 5 is 60, times 2, that would be negative 120. And 13 times 13 would be 169. You can walk through the second two examples in the book. They just use for cos 2 theta, they use the identity that's equal to 2 cos squared minus 1. Here's cosine squared, 5 over 13 squared. That's how they get 25 over 169. Multiply that by 2, subtract 169 over 169. That's how you get this answer. And tangent of 2 theta is 2 tan of theta. So over here, the tan, opposite over adjacent, negative 12 fifths. So that's what they have put in here, 2 times negative 12 fifths over 1 minus negative 12 fifths quantity squared. Order of operations, do this first. This is 144 over 25. This would be 25 over 25. 25 minus 144, I'm not exactly sure what that is. Multiply that out, flip that guy and multiply. And you could check your math on that. Make sure you get 120 over 119.